so that exactly. So hello everyone. Welcome to day 4 of our AI ML for Developers Bootcamp. It's another day to learn, another day to get that knowledge, another day to write those code, another day to dive into Python, data science, and all of that. Right. So thank you guys for joining in again. Today is day 4. We are going to day 10. But yeah, it's been a good ride since day 1. And you guys are here again. I won't say too much, and I'll just allow Mr. Nehemiah take over so that he can do his magic, right? Yeah. So, Mr. Nehemiah, are you there?
Yes. Hello, are you able to hear me?
Yes, I can hear you loud and clear. So,
All right.
before you came in, or
All
maybe when you were
right.
coming in,
Mhm.
we had somebody saying that they didn't get some things from last class. So, we'd love that you like do a bit of summary before like moving to new topics. Thank you very much. You can go ahead.
All right. Thank you so much. And hello, guys. I believe you are doing good wherever you are. And welcome to today's session. Just a recap or maybe the Python fundamentals, because we said it's the core technology in this program. Okay, data science. Okay, machine learning, and artificial intelligence. Like Python is the core technology. That's why we are learning it. I know in the call we have people who are experts in Python, but then we have the intermediates and the beginners. So we have these Python fundamentals to bring up to speed all the beginners. And I want to share my screen. I want to share my screen. Let me see. Are you able to see my entire screen? I believe I'm sharing the entire screen.
Yes, I can see your screen, Mr.
Are
Nehemiah.
you guys able to see my entire? Okay. All right. All right. So let me quickly just talk about what we discussed last time, though we are not going to details because we already have the recordings for that, but just to mention, first of all, last time we said that Python is the core technology in data science in this program, of which data science, when I mention data science, I mean um, from the data collection, data cleaning, data, deploying machine learning models, optimizing the models and all that, like data science, like at the full cycle. But then in this program, we are focusing on the machine learning and artificial intelligence programming language that can help us interact with the machines because it doesn't allow us to, to like command it directly. Like we need to use some way because I only understand the binaries. So we use the programming language like Python now to instruct machines to do specific task, if it's machine learning task or whatever kind of task it is. And then we introduced Python last time, and we said that there are some things that you need to, especially at this time where there is an advent of artificial intelligence and all these things. Like you need to have a clear roadmap so that whenever you are learning technology, like for example Python, you don't have to like run everything, like learn. In fact, even me, I don't know everything in Python, but provided I have the roadmap, I can, as I progress, I can continue to learn Python and other things in Python. But we say that the key thing to learn on a programming language, if you want to master it well, is first of all to understand the variables, how variables are defined. And then the other thing you need to understand you need to understand the data types and the data structures, essentially including the lists, the tuples, the sets, dictionaries, and then you can also learn the functions, function and modules. And then if it's an object-oriented programming like Python, and then you need to understand also how to work with the, classes and objects. A class is like a blueprint for creating the objects in Python. So you need to understand those things and also how to deal with the files, file handling as well. But in a nutshell, you need to understand how to work with the variables, understand the data types, understand the data structures and algorithms, and also understand the object-oriented programming if it is a language like Python. And we said last time that variables is like a container for storing data values. It's not like I demonstrated it with an example. I, I demonstrated with an example, like for example, when someone tells you, "Get me a cup of coffee," they don't mean that you give them like an empty cup of coffee, but they mean you give them the cup, but that has coffee in it. So that cup is like a container for the content, or maybe the coffee in that cup. So in a variable way, for example, when you say A, you assign it to a value like 100. So this equal operator, you're not equating. Can you give me a second? Just a second. Just
Hello, everyone. Can you hear me? I can't hear Mr. Nehemiah from my hand. Can you use your chat to let me know if you can hear me? Okay, I think Mr. Nehemiah is having issues with his internet. Would have to wait for him to get back. Okay, we should give him a second. Okay, great. Hi, Mr.
all
Nehemiah.
right.
You cannot talk. Okay.
All right. Thank you so much. Thank you so much. Sorry about that. I think there was some background noise. I don't know if is it calm now? Is my background noisy?
It was a bit noisy, and I guess that's why I did muting everybody. So I didn't know that it was from your background. I thought it was from somebody else.
All right. All right. Thank you. Thank you so much. All right. So I was talking about the. Are you able to see my screen still?
Yes,
You
your
can see
screen
my
is still
screen.
visible. Yes.
Okay, thank you. So, yeah, we said that it's just that variables, these are just containers for storing data values to be used later. Just like, for example, you can have a water tank to store water to be used later. Don't worry. Sorry, once again. I was talking about the variables. And I said it's like containers for storing data values. So it doesn't mean that it is you're equating. For example, in this case, let me zoom in. When we say A equal 100, we are not equating. We are basically assigning this 100 value to a variable A. And then Python is not like other programming languages, like where you have to declare a variable with the keywords like a late, var, or a const. This one, as soon as you assign a value to it, you have you have declared a variable. And then we say that it can store the variables can store multiple, like a different data types, can store different data types, like the text type. We talked about the text types, like the strings. We talked about the numbers, including the integers, including the floating point numbers, the complex. We also talked about the booleans. We also talked about the other, we talked about some other things last time, but then today I want us to focus now on the data structures and some of the algorithms as we progress, And first of all, I said this is a very, very key concept to learn on any programming language. And in this case, Python, it's a very, very important thing to know how to work with the lists and the tuples or tuples, and then the sets and also the dictionaries. So these are the key things that you need to learn in the data structures in Python. And then after that, you can now, I believe you'll be good now with Python. So I have these slides here. I think I'll share with you. I'll share with you these slides. Uh, I'll share with you these slides, but allow me just to talk about it. I want us to begin with the lists. I want us to begin with the lists. And the lists, these are used like last time we were talking about the variables where we could store a single variable, for example, a single value, like for example, if it's just a string, a number, or a Boolean or a different data type, but the variables can as well store multiple items in a single variable, like a variable, like a list can store. It's like a collection to store multiple items in a single variable. Like you can store multiple items in a single variable. So one of the data type that you can use to store multiple items, one of them is the list, and we are going to talk about the list in details in a few. But let me first of all write for you their characteristics. Though it is in that slide I'll share with you. So lists in Python. So first of all, lists are ordered. Remember, it stores a collection. Like for example, let's say you have a list of fruits. In that fruits, you can have, for example, fruit like mango, apples, and all that. So it's storing more than one item. So that when it's storing the item, like it's storing in an orderly way, like the way you arrange it, it's the same way you'll get the output. So the lists are ordered. We are going to demonstrate this one in a few. And then another characteristics is that the list, the lists also are changeable. Like once you define, you are able to change. Like it is mutable, like it's changeable. You can change. And then it also allows the duplicates, and then it allows the duplicates, and then it is in Python, it is defined in square brackets. It is defined in these defined in these are square brackets, and so these are the key characteristics of a list. And I want us to demonstrate or maybe prove these attributes or characteristics. First of all, I want to use just a simple variables here just to illustrate, like for example, fruits. Let me use an example of fruits just to see how we can store like variables. Initially, we were storing, for example, simple things like lists, okay, like an integer things. But then now we can have what? We can have a list of items, and in this list, you can have things like for example, mango, just for example, and then pawpaw, orange, and then, for example, grapes, or whatever kind of fruit it is. So, who remember the function that we were using to check the we were using to check the data type? Let me see in the comment. Yeah, we are using the type function. Thank you so much. So here we are going to use now. Remember, we usually use the print statement in the event we want to execute anything here, the terminal. So if we want to execute anything, we need to use the print statement. But the notebook, it understands. It understands in case just write, like, for example, fruits. We just define fruits and then we say fruits. You can be able to execute, like, you can get the output, but it's not the case in all IDEs. So if you want to, like, execute properly in like in different IDEs, then you must use this print statement in the event you want to get an output. Now, because now our output wanted to tell us the type, the data type. So here we are going to use the type function here. And then here we are passing our object or our variable, which is fruits. Which is fruits. And then you can see it is a list. It is saying it's a list. And as you saw earlier, when we were trying to run without this type, you saw we got the output here. So this is the output. You saw we defined with mango. We began with mango, purple, orange, and grapes. But then the output is still mango, purple, orange, and grapes. So which means that this list is ordered, like it's orderly, like the way you define it, the same, you will be able to get it. So if something is ordered, it means that you can be able to do it. You can be able to access the elements with their index number. You can be able to access their elements with their index number. Index is like the position of things. Like, for example, let's say you are aligning some people here on the front. Then I want to, for example, count people, the number of people. Perhaps you say, number 3. You'll be able to call, for example, number 3, and then they will not identify themselves. So, which if something is ordered, it means that you can be able to access based on their position or their index. So, indexing in Python, it begins from 0. So it begins to count from 0, 1, 2, 3 onwards. So if this list is ordered, and we say that we can be able to identify the elements with their index, then, for example, if we want to retrieve only something like, let's say, mango, who can tell us which purple. Which index is this purple element, purple here? Yes, 1. Thank you so much. Yeah, so we are going to use here 1. We are going to pass here 1, and then we'll be able to do it. We'll be able to get retrieve the purple. So this proves that it's ordered. You know, something which is not ordered, you'll not be able to access their position. But then because it's ordered, we are able to access the index. Now, in the event, for example, you wanted to access the range, you still be able to do that. Now, if you want to access the range, you need to use the colons. You need to use the colon. For example, you say that you want to access, for example, from index 1 to, like, I want to get the purple to orange. Then you specify, first of all, the starting point, of which is, this case for purple is going to be 1, because this is 0, and then this is 1. And then you need to specify the ending index on your range. And I remember, whenever you're using let me give you the syntax here. Whenever you are creating the range, in range, or maybe in slicing, let me use slicing. Remember, I'm still referring to the range slicing. Slicing, it always include the starting index, and then it includes. Okay, let me say it includes the starting index. It separates. and then the last index, you -1. Okay, how can I put it? -1. So in a range, the last index is always -1. Like for example, if you say, like I want to get from purple to orange, and I will know this is 0, 1, 2. This is index 2. For example, if you wanted to define to get a range up to these 2, it means that I will need to we need to do what we need to like add in an extra one because it always subtract 1 from the last index. Because if we just say here 2, then you can see it's now returning only purple. But then it means in this case we need to do what we need to add in an extra one so that when it subtract 1, then we'll be able to get our range. Remember, the first index is always included, but then the last one, it is subtract 1. But then assume this case where, for example, you wanted to do what you wanted to get like up to the last index, where you wanted to like retrieve, because we know that on a range or maybe when slicing, you need to do what you need to like subtract 1 from the last index. So for example, if we try to say, for example, we want to get from purple to the grapes, and we know that we always need to add in an extra index, then it's going to be a big problem here because this is 0, 1, 2, and then this is 3. So for example, if we add in 4, and we know we don't have position 4 in this case, like the elements reach at index 3, we have 4 elements, but their indexes begin from 0, 1, 2, 3. So when you add in 4 here, we'll get an error. We will get, oh, it has worked, but it shouldn't. It shouldn't, but in this scenario, let me see. Okay, it's working, but I thought it shouldn't. But then in such scenario, at work with this stuff well, then you'll need to just specify the, for example, if you want to get like everything from the specified index to the end, then you need to separate it with a colon so that you don't specify the last index because you want to add it to the very end. So in this case, you'll be able to like retrieve the elements from the specified starting index to the very, very end, very end. Yeah, so, and then I want someone, for example, to give me an example or a code that I can use, for example. Let me add in here, pineapple. So there's this code there, and there's also this list. Who can tell me, for example, if I wanted to return the range, like these elements from mango to orange, which code should I include to slice or maybe to specify that range? Anyone who wants to? Let me see. Yeah, nice. Thank you. Goodness says that we need to specify print. Okay, let's say print. Okay, so it's already print, but then now we specify now the objects where we want to slice, which is fruits, and then we specify the starting index, which is 0, but then we said that we need to add to reach at orange, so we need to specify the starting point, and then the last index where we want to like access that element, we need always to add in 1, so this is 0, 1, 2, but then because we want this orange be included, then we need to add in an extra index. So in this case, when you add in 3, we'll be able to retrieve up to orange. Now, another way, for example, if you want to return from mango or maybe from the start to orange, because we know 0 is like at the start, like you want to get everything from the start up to a specified range, then you don't need to specify even the 0, the first index, because it means that you want to get everything from the very start to the end. So in this case, we just specify the colon and then the end. The end, for example, if it is at index 3, then it means that it's going to return up to elements at index 2. Yeah, so this way, still you're able to access with the without specifying the starting point. And sometimes you might also want to slice with the negative indexing. sometimes maybe the item that I want to access, it is from the, let's say your list is very, very long. You want to access the items from the very farthest end. So it will be a hassle for you to do it, for you to count, for example, 0, 1, 2, 3, up to that way. Like, for example, if you are doing manually to get it to the very last end. So the best approach is to use the negative indexing. Now, we say that indexing begins from 0, like if you're going from left to right, 0, 1, 2, 3, onwards. But then if you want to come from this other side, then here is going to begin, like this one is going to be negative 1. This negative 1, negative 2. Remember, it doesn't begin from 0. Remember, when you specify 0, it means that you want to begin from this other side. So this one begins at negative 1. Negative 1, but then remember the rules on the indexing or a slicing still apply. In the last index, it always exclude 1. Slicing include the starting index colon the last index minus 1. So this is the syntax. Let me just specify here. Okay, let me use here in a new one. So this is start colon then end. End like that. So whenever you want to slice. Now, for example, if you want to do it from the negative indexing, and we say that we begin from negative 1, like at the very first index from the right, it's going to be index 1. So you can tell me with the negative indexing, how can I get the range of, how can I return orange and grapes with the negative indexing? Let me see in the chat. To access the range for, or maybe the code that is going to return both orange and grapes with the negative indexing. Negative 3, negative 1. Wonderful. Wonderful. So we have this negative 1, negative 1, negative 2, negative, and by the way, guys, I believe you guys know that, for example, if you have negative 1,000,000, it's very much smaller than negative 1. So negative 1 is always smaller. Okay, largest. It's largest. Like if you are moving to the negative direction, then negative 1 is the biggest, is the largest. And we know that whenever you're doing the slicing, it should be ascending. It should begin from the very smallest to the largest. So in this case, the very smallest index should be in the negative direction. So for example, if this is index negative 1, negative 2, then negative 3, we want to include this orange. So it's going to be negative 3. So this one is going to be our smallest index, negative 3. And then because we want to reach to grapes, the same way someone has said here, we need to specify index 1 to include, like to add in index 1 so that it will when it subtract. But then in this case, it's going to add, so that when you add, it's going to counter the negative alafita to reduce. So it's going to be minus 1, so that when you add, then it's going to like reduce to this one. I don't know if it's adding or what, but then orange and grape. So this one is going to return orange and grape. So this with the negative indexing. So I believe by now we have demonstrated that the lists are changeable. Okay, the lists are ordered. We have understood that the lists are ordered and that we're able to access their elements with their index number. And then I want to also demonstrate this aspect or attribute of lists being changeable. So we want to see if we can be able to change. For example, once it is defined, are we really able to change? So let's try. Now, because we can access their index. For example, let's assume we want to modify this index 0 to be another element. So we'll still use fruits, which is our object, but then we don't want to return everything or maybe focus on everything. We want to just focus on, on the first index, which is 0. Then we're able to do it. We're able to change to assign it to a new value. To a new value. By the way, we demonstrated the other day that Python is dynamic. And for example, when you say A, you give it 10, then B, you give it 20. Okay, sorry, not B, but A, another A, you are reassigning to a new value like 20. Then it's going to, when you print, it's going to return what? It's going to return now this one, the latest one. So it's very dynamic. Python is very dynamic. So in this case, when you try to update, for example, when you specify the first index, initially it was mango, but then now you are trying to access the first index, but then you assign it to a new value like, I don't know which fruits, banana. Then when you try to print, okay, when you try to do it, when you try to print the fruits, the fruits, then you'll be able to do it. You'll see that you have banana. So it means that the license is defined. You can be able to change. So these are very important attributes to understand. In fact, you can also include. Okay, you can as well append or maybe add into the existing list, like adding more items or modify the existing parts. So this just to demonstrate its ability of it being changeable. Let me see the slides if I have, let me see the slides if I have those attributes. But then, guys, if it's not included, make sure that you are writing your short notes. Make sure that you are writing your short notes. Yeah, so these are the methods that you could also include. Append, this is the method. For example, if you want to add in another item at the very end, you can use the append method. If you want to remove an item, you can use the remove method. Then you specify. You first of all begin with the object. For example, you say the fruits, then you say dot remove. We are going to talk about the objects, the classes and objects in a few. But then these are the methods you could use. This to remove item, and then at the pop, this is to as well remove also the elements. Then for example, if you want to sort, you can as well use the sort method. So we'll talk about this one as we progress. But then let's also try to demonstrate another aspect, or maybe try to understand the other attribute of the list. So we say that it also allows the duplicates. So let's try. Let's have here. Let's have what? Let's have here. So this is our fruits, but then I want to intentionally duplicate some elements and see if we'll be able to get the same output. So now when I print fruits, you can see that the output is still having 2 oranges. So it allows what? It allows the duplicates. Remember, there are several or maybe many methods within this being able to change, like I showed you earlier in the list. But then we are not going to talk about that. But then we have many other methods. For example, to change. For example, if you want to add in, arrange, and all that, to specify, arrange, and replace with the new values and all that. So we have several methods, including the sort, but just to demonstrate a few of it being changeable. I think it's clear now because we have demonstrated that one. And also, it allows the duplicates. It is defined in the square bracket. So these are the attributes or characteristics of a list. So once you master these characteristics, then you'll be able to know how to work with such data structures. Now, I want us to talk about, okay, is it clear? Is the list clear, guys? Before I talk about the tuples, have you understood? Wonderful. So the thing is that you need to just know these attributes of the list. Once you know these attributes, then you'll be able to know, for example, which methods. You can just do a research and know, for example, what methods can you use. For example, if you want to append, I showed you earlier, but some few in the slides, like append and all that. But then, provided you know these attributes, then you'll be able to research on what method can you use, for example, to concatenate. In fact, concatenation is just to have one list, then you add in another one with a plus operator and all that. But then let's talk about something else so that at least we cover everything. So let's talk about the tuple still on the data structures. Let's talk about the tuples or tuples, depending on how you could read it. So I want us to talk about now another data type for another data type for storing like a collection or a sequence of data, and that is the tuples. And tuples in Python is similar to the list, like they are ordered. Okay. Um, okay. So it should, should be I should be tuples in Python. Python. So these ones are still ordered. Are still ordered. I'll just look at the list, but then these are immutable. These are unchangeable. Like once you have defined it, you cannot change. So the only thing is that they are unchangeable, so that when you're dealing with such data structures, you will be able to know its attributes or maybe characteristics, so that whenever you're writing a program or maybe an algorithm to solve a particular thing, you'll be able to understand what kind of data structure you're using. Or maybe data type. For example, for the tuples, the only difference here is that they are unchangeable, but then it allows the duplicates. But then this one is defined with the rounded brackets like this. It's defined with the rounded brackets. Let's demonstrate this one first. And I believe I'm just going to use my list like these fruits. I don't want to like retype everything again. And just have it here. The only thing difference here in the tuples that is defined with what? It's defined with the square, not square, but then this rounded bracket. So when you run, you can see we have this output. But then let's try to see if we can get the data type. So if we want to get the data type, what should I do, guys? If I want to get the data type of this object, let me see in the chat. Anyone to get the data type of this object? Yeah, type fruits. We're going to just use the type function, and a function in Python must have what? The parentheses. A bit function or methods must have the parentheses. Then and then said you can, for example, if that method it takes argument, you can pass in what? In this case, if it's a built-in type function, then this means that you need to specify what the object in Python. Everything is an object. So when you say here type, the data type of that value. So this is a tuple. And then just to demonstrate, first of all, okay, let me see. So these are object fruits. Now, first of all, I think these fruits, it has what? It has a duplicate. You can see we have orange, and then in the output, we can also see we have orange. So this straight away demonstrate or maybe clarifies this part that it allows the duplicates. And then another thing is that it's ordered. So you can see we have mango, we have purple. This order is the same that we are getting the output here. So it is also ordered, and then it is unchangeable. So if it's unchangeable, okay, let's try. So in the list, we are trying to specify the index. Remember, if it's ordered, you're able to do it. Who can help us know how, for example, we can access, for example, this purple? How can we access this purple? What program should I write, for example, if I want to access this purple and this tuple? With your list knowledge, we talked about the list. Yeah. Thank you. So let's specify with the index 1. So when I say 1, I am getting the output. Why? Because it's ordered. Something which is ordered, something which is more ordered means that you're able to access the elements with their index. You're able to access the elements with the index. Similar to the range, how you can access the range, because it's ordered, you can still access the range with the same trick or a method that we used in the list because it is ordered. But then the only difference is that, for example, on these elements, on these tuples, you cannot change. You cannot change. For example, when you say, for example, on the list we were saying, we were specifying the index and then we are trying to change. But then in this case, because we said it is unchangeable, let's try to approve it. So we are going to specify our object, which is fruits. And then we specify the index, for example, index 0, which is mango. If we want to change to assign it to a new value, like we used we used pineapple. Don't know if this is a spelling for pineapple, not sure, but it's just fine. Now, when I run this way, I'm going to get here this error. Okay, sorry, I forgot. So when I run, I'm still going to get what? I'm going to get this error because its characteristics that it is immutable. Like once it's defined, you cannot change. Once it is defined, you cannot what? You cannot change. You cannot change. And then if you cannot change, you cannot use some methods. You can just tell if something is unchangeable. You'll know that methods like append it will not work there. Let's see. Okay, it's not included. By the way, guys, you can write it now on your summary on your notebook, or some character or attribute that are not in that slide. So you can have them on your short notes. So we have those methods that will not definitely work here. If you cannot change, it means that you cannot append. Append is like adding like elements on top of, adding the elements, elements at the end. For example, if you have this list, it has switched here, then you want to add in like a more to append. To concatenate is somehow different from appending. For example, if you have this, let's say we have this tuple. Here we have 1, 2, 3, 4. 4, and then here we have B. We begin from, for example, 5, 6, 6, 7, 8. And then to concatenate, you could have used, for example, A, then plus B to get like a continuation of a list. Okay, like combined tuples. Remember, guys, this is still tuples. Whenever you see this rounded brackets, just know it's tuple. Whenever I confuse and call it list, just know that it's a small mistake. I'm still referring to the tuples. Now, whenever you see this thing, we have not modified. We have not. Remember when you use append, this one you are trying to modify. But then in this case, we are trying to concatenate. If you say, for example, A dot append B, and then you print here A, it will not work. Why? Because it is immutable. But then this when you try with the list, when you try with the list, let's see the output. So you can see, okay, so basically here we just need to specify one item because basically append method, it only takes one argument. Like you need to just specify one value. For example, if it is, for example, something like 8 or whatever, and then you're going to, I think this notebook, it doesn't have, okay, sorry. I was noticed the issue here. I used, but let me undo. I noticed I was trying to append A to A. Let me see. Yeah, so you can see. But then remember now the append, it only takes one value. That's why it's now trying to like include it in the form of a list. Otherwise, you could, if you say, for example, 5, okay, 6, then you can see now it's adding, like this one is modified. When you try to print here at the bottom, when you print here A, you can see it is modified. But then the concatenation process wasn't, modifying, just to combine, not modifying. the original value. So you notice that you cannot do what? Appending, you cannot use the append method because it is what? It is immutable, it is unchangeable. And then also we have demonstrated that is defined with these rounded brackets. So I believe that is clear. So remember, there are several methods that works under these aspects, these attributes being ordered. There are several methods that you could use, for example, to access the the elements, the slicing and all that. But then just to demonstrate these attributes. Remember, the key thing is just for you to know these attributes of the data structure, such that in the future when you are working with such data structures, you will be able to know if you can manipulate that data or not. If not, what should you do? And who can tell me, for example, if I wanted to modify, we know it is immutable. We have demonstrated here it's immutable. Who can give us, for example, the hint on how we can do it, on how we can be able to modify this tuple and still get the output as tuple? Who can guess what we'll do? Or which technique or which concept can we use to convert? We know it is immutable, but then we can use some other steps, but then still be able to convert this tuple. Someone says slice. Another person? Yeah, list. Using the list constructor, we can use the type conversion trick. You remember type conversion? We talked about it, I think, on Saturday. The type conversion trick, such that we can convert these because we know the structure. The structure is similar to for a list. For a list, and the tuples, like the structure here is similar. It is ordered in the it's just like individual item, not like a dictionary key value pair. It's just individual elements. So the only thing that is changing here is just these parentheses. So in this case, you could use an approach of type conversion, such that we can say, for example, we can get here converted or something like that. Remember, variable should be descriptive. Converted, something like a structure. Remember it just for a demo, but then for you, make sure that you're using a correct variable that resembles or maybe matches what you're trying to do. So converted structure here, we'll do what? We will use a list constructor to convert what? These fruits of which is a tuple to a what? To a list. This is a tuple, then I will be able to do it. We'll be able to convert it to. Now, when you print this one, you'll be able to see that. Sorry. First of all, let me see. So these are our fruits. These are our fruits, of which is a tuple. But then now we are trying to use the list constructor here for these fruits. And then now we are trying to, once it is, first of all, let me see the output. Before we get there, let's see the output. So the output is still a tuple. And then here we're using the constructor. I don't know why it's perhaps the memory. Let me save and see. Restart this notebook. I think it's out of memory. Let's try again. Hello? Oh, sorry. You've noticed that I'm still passing here fruits instead of this new variable. Oh, sorry about that, guys. So we need, because now this variable, the one that is storing what is storing this converted structure, because when you pass here fruits, it's the same thing as you're trying to print out these fruits. So here it should be this converted structure. Then I can see now the format has changed. Now it's a list. So if you use a type, then you'll be able to go. The output will be a list. Initially, it was a tuple. So once we've converted it to a list and we know the attributes of a list, so it means that we're able to do it, we're able to convert it or to modify. So in this one, because this is the one that's stored in the list, we can specify the index, which, for example, 0, and then assign it to a new value, a new value, like we said, we used, I don't know, it was pineapple. And then let me just remove this type, whatever. So I can see we have modified, but then the output is still, it is still a list. So it is modified, but then the output is still a list. So who can tell us what we can use to get like the output being a tuple? How can we make the output be a tuple? Anyone? We've managed to convert it from a tuple to a list, and we have modified that list because we know that the lists are changeable. But then once we've changed the output, it is still a list. So we want to So people have given us the constructor. Still, we are going to use the type conversion, and then in this case we'll be using the tuple constructor. So we'll be using the we can just still use in fact the same variable because variables in Python are dynamic. We discussed that, but then now in this case we'll be using the tuple constructor, the tuple, and then what will be our object in this case is going to be this list. So the output is going to be sorry. Okay, I need to use now fruits. Don't know I forget this. So these are the techniques or tricks that you could use to go about such things. But remember, still the attributes of a tuple still the same. They are unchangeable unless you use the type conversion and modify. It allows the duplicate. We saw that it is ordered. So I don't know if there's any question on the tuples before I go on the sets. Is it clear on the tuples or there's a question? Is it clear? Let me know in the comment if you've understood. Wonderful, wonderful, great, great. All right. I'll assume that's the case for everyone. So the other thing that I want to talk about still on the data structures, because I believe once you understand these structures, then you'll be able to know how to deal with such data. Because if you know that a tuple is unchangeable and you have such kind of a data, and then you know it's going to be difficult. That's why it's very key on any programming language to understand these data structures. Because if you don't understand them, then you will not understand what data structure to use. For example, in the event you want to update in the future, or maybe if you want to retain the structure, you don't want to modify the original values, what data structure will you use? If you want to modify, what data structure will you use in such thing? Or maybe if you want to get an orderly output, what structure will you use? So these are very key things to understand. Now I want us to talk about the sets. The sets still on data structures. Still on the data structures. First of all, to remind ourselves, um, to remind ourselves, we say that the lists are what? The lists are ordered, the lists are changeable, the list allows the duplicates, and it's also defined with the square brackets, and the tuples, they are well ordered, but then they are not changeable. They are unchangeable, and also I still allow the duplicates, and it's defined with these rounded brackets. But then we have other things called sets. Sets in Python, another data type, data type that stores a collection of data, like more than one item. So, but then guys, there's another thing that we need to include in all this. In Python, like including the list, tuples, sets, and also the dictionary, it can store This is another characteristic that I should include in all. It can store different or multiple different, different or different or multiple. Remember, either of these, it can store like a different or multiple data types. I think okay, it can store. Okay, I think there's a way I could say it stores any data type. I think this there. For remember, these are now applies for both for all. Let me just include here in case someone will want the notebook, so it will have it for all. And remember, just for all, like remember variable. These are just characteristic of variables. Like it can store any data type. Any data type will mean it can as well, these tuples can store as well lists inside. It can store integers. It can store integers. It can store booleans. For example, if you add in here a boolean like a true, it will still do what it is still store. It will still store and all that. Now let's talk about the sets. Now sets still they are used to store multiple items in a single variable, just like the list and the tuples or tuples. This one I used to do it. I used to store a collection of items or a sequence of items, and then now the opposite, unlike the list and the tuples, these ones are unordered. These ones are unordered. If something is unordered, it means that you cannot access their elements with their index number because it's unordered. You're not sure what position an element is, so you can not be able. You can just know it's going to roll out that ability of it being like accessing the elements with their order. In their index with their index because it's unordered. And then another thing about this sets, similar to the tuples, these are unchangeable. These ones are unchangeable. Like once you've changed it, you cannot what? You cannot once you have defined, you cannot change, sorry. Once you have defined now the sets, you cannot change. And then also does not allow the duplicates. So unlike these other ones, this one does not. So I should just say here does not allow the duplicates, and also it can store data of any type, and then it's defined with curly braces like these curly brackets. So we want to demonstrate this one also. Now let me have for a collection a variable here. We say that's defined with what? The curly brackets. Is defined with the curly brackets. And then one of the characteristics, we say that it's unordered. Unordered means that you don't have like we know in this case it has begun with mango. So in other cases, for example, the tuples and list, the output, for example, was to be when you pass your fruits, the output was to begin with mango, purple, but then you can see this one, it has begun with purple, then pineapple, then orange, grapes, and mango. So it doesn't have like the orders like what we had in the list and the tuples. So now in such case, and also the other thing that we also notice here, we had two oranges. But then the output is only one. It includes like only one orange. It only includes like one orange. So it means that it has filtered out the orange. The other orange. So this one does not allow the duplicates, and then it is unordered. It's unordered. If it's unordered, it means that you cannot access the elements with their index. So let's try to demonstrate this one. So, and by the way, guys, remember that when you're working with a notebook, if you define something here at the top, you'll still be able to access the same variable. Remember, it's still the same file, only that there are different sets. But then because I'm teaching, I'm trying to, as much as I can to like redefine everything in a new cell, like like I do everything, repeat everything in each and every cell. But for example, if you say print fruits in this new cell, you'll still be able to do that. You'll still be able to get the output because it's still remembering what you had written in the first cell. So remember, this cell doesn't mean like there are different things. It's still the same file. It can recall what you had written in the first cell, provided it was active, like you had run it to be in the memory. But then, because I'm teaching, I want to demonstrate everything in each and every cell. And you notice that I'm using symbol examples to illustrate things. But in a production level, or maybe if you are working on a project, you won't be writing these things. But then I'm trying to use these symbol things to demonstrate these attributes and how Python works. But then if I want to do something, and then it's going to be a little bit complicated because you need to also include other things as well in the inside. But what you need to do at the moment, just know this syntax or these structures, then it'll be good to go. Now let's try to demonstrate. Let's try to check if we can really modify with the index or not. So here is our fruits. We said Python is dynamic, right? Said Python is very, very dynamic. Like once you've created a variable, and then you assign it a new value, you reassign a new value, it's going to do what it's going to use it. So in this case, in these fruits, we want to access what? For example, mango still, which is at index 0, we know. If it were in the case of lists and tuples, it's going to be index 0, this mango. So if we could give it pineapple, pineapple, I believe this is spelling. In other cases, it should have brought the output, but then in this case, we are getting the error. Why? Because it doesn't allow what it does not. It is unchangeable. It's unchangeable. It's unchangeable. And then another thing is does not allow the duplicates. We saw that one earlier. And then you can store any data type. So let me try to say, for example, 100 or whatever it is, 100. And then you can see now we are getting the output is 100. And also something about sets, now that it doesn't allow the duplicates, there's some attributes that guys you need to know about the sets, especially in the joins. Remember, you can perform the, on sets. On sets, you can still be able to remove items, but then with some methods, for example, the discard, remove, and all that. But for some other things, just a second, let me see. So you can do the CRUD operation still on the sets, but consider sets something like this. Something like this. I believe most of you learned this one in high school. Like and then this the intersection. Is it intersection? Yeah, intersection. This is intersection. Intersection, like it's trying to get like elements which are both in the first set. Let's call it this one A, then this is B. So on the, for example, if you want to join elements, you want to join sets together. Just know that, for example, if you have set A and then set B, now when you want to combine them using either the update or whatever it is, just know that it's going to automatically filter out these duplicates. Yeah? What is both in A and B is going to like a filter out because it does not allow the duplicates. It does not allow the duplicates. And by the way, we have other methods as well in the sets. And this thing, but there I'll try to include it in the slide so that you can try to learn more about the same. But just know that the same is how you learned in high school. For example, the unions, the difference, symmetric difference, and what else? Intersection is still the same thing. Okay, let's try to demonstrate one perhaps. Let's assume that we have set A. We assign it to, for example, 1. Okay, sorry. This is 1, 2, 3, 4, 5. And then B, in fact, I should have just even written B. I'm going to use For example, 4, 5, 6, 7, perhaps to whatever it is. So the output, when you say you want to concatenate, in fact, without even using the any method, you say, for example, you want to get print, you want to concatenate, right? You want to join A and B, and you say, for example, A, M, and B. Okay, A plus B. This one does not support concatenation operation, but then you can use the method like update. For example, you could say A. You could use you could use you could use add, but it's add. You could use add. Okay, on the join, sorry. Remember this one in the event, for example, you want to add it to the original one. You could use the add, but then, for example, on the join, you could use a method like union or update. So, for example, say A union, A union B, A union B, and then you print out what? You print out A. So you can see now the output we are having 1, 2, 3, 4. But then 1, 2, 3, 4. Wait a minute. Remember this one should return. Let me use this method because I was expecting. Oh, let's use a new variable. Let's say C. Let's say C, and then we print out C. Or we print by day. That was a mistake. Okay, sorry. So C. So in this case, the output you can see now we are not having the duplicates. We in the A set A we had 5, 6, 4, 5, 4, 5. This other one we also had 4, 5. But then the output we are not getting that one because it does not allow the duplicate. So this is on the union. On the update, you could use things like still update is the same as union. The same as union. And then so on the update, you could use whenever you use like things like the update. In this case, you should okay, let me see first of all if it's going to work. I talk about it. Yeah, so for example, if you are using the update, it means that you want to modify the original. You want to modify the original. If you want to like do the set, then in this case, you don't need to create a new variable because it means that you want to modify the original. In this case, what you're trying to modify is A, but then we're updating with B in this case. But then you could use the join, okay, what do we call it? Union, so that you can create a new variable and update it. Now you could as well use union. On the union, you can use still, for example, if you don't want to use the method, you could use the pipe. The same as union. The same as union. This one is the same as union or update. And then apart from the union, we have things like what do we call it? We have the intersection, things like intersection. But then, guys, I'm not going to talk about these ones because it's like so A dot intersection, and then you can specify B. So basically, for the intersection, this one is going to like only return the values which are both available in A and B. So it's going to like returning only items or only duplicates items or items that are both found in A and B. We demonstrated here. So this is the intersection. Like it's trying to only return items which are either in A and B. Okay, they are both in A and B, not either. So they are both in A and B. So it's going to like these items alone that are there in that intersection. So when you use this one, then it's returning 4 and 5 because we have 4 and 4, 5 here, 4, 5 here. So because it does not allow the duplicates, it could not bring 2, 4, and the 2 5s. And then, for example, if you wanted to update the original, then you could have just specify here the update still, update. So this is in the event, for example, you want to modify the original, of which you know the original here is A. So when you print here A, it means that you are modifying the original. Whenever you use extend with the update, it means that you want to modify the original. And then we have things like the difference. Who can tell me the difference, guys, in the chat? What does the difference do? So I know that perhaps could be long to type, but just know that the difference is trying to like get the items that are in A, For example, when you say you want to say A difference B, it means that let me get what in A and not in B. Yeah, this is very correct. Like this one is trying to get items that are only in A and are not in B. So it means that if you have the duplicates here, in this intersection part, then that part is not going to be included in A. So it's trying to like just remove, like it's trying to get only this other area, this area. Then from this other end to the other side, it's not going to be returned. Like it's trying to only get items that are in A and not in B. And then, okay, that's on the difference. Then if you wanted to update, what could you do? Just add in the method update there at the end. It means that you're trying to modify this when you add in the update underscore update. It means that you are updating what? You are updating A. So when you print out here A, it will be updated. You can see now the value is updated. It was originally this one, but then it's now updated. So this in the event you want to update, you need to just use the update. Remember, you can as well do, for example, with B. You can as well say, for example, a B difference A. Then it's going to like a return only for items that are in B alone and not in A. And then we have the symmetric difference as well. We have the symmetric difference. Now for the symmetric difference, this one tries to get only items that are unique in A and B. It's not going to get those that are here, this part for symmetric difference. Let me just use here. Symmetric. Symmetric, I believe is the spelling. Symmetric, I think it has double M somewhere. Symmetric difference. And guys, I might not find it in the slide, so make sure that you might sometimes be writing your short notes, though the recording will be provided. So when you say here C, and then what I should have asked you first. Basically for symmetric difference, this one is trying to like return unique items in set A and a unique items in set B. So it's going to like remove the duplicate. So this for the symmetric difference, like a difference, the difference from the normal difference. Remember for difference, when you use the difference method, this one is only focusing on one set. Like it's trying to get only the item that are uniquely at A and not at B. They are not found in B, or maybe items that are in B and are not found in A. Remember the values that are here, to mean they are also found in A. So if you want to get the difference in B here, to mean that you're only focusing on these other, in a nutshell, the sets. If it's another, you cannot access the elements with the index. It's unchangeable. It is unchangeable. We demonstrated earlier that it is unchangeable. And then also it does not allow the duplicates. And I remember behind all these attributes, we have some methods under it. I tried to include it in the slides. but we have other things. Remember, this is just a refresher. We'll have the main course soon, but for beginners, this is what I think this is what you need to know, the basics, so that it may not be complicated to you. Now, we have another data structure. We have another data type that stores like a sequence of values called the dictionary. Okay, before I go there, is there any question? Is it clear on the sets? All right, Holy Ghost. Holy Ghost says it's clear. Clear, yes. Okay, great. All right. So let's talk about the dictionary quickly. Let's talk about the dictionaries quickly. The dictionaries. Let's talk about the dictionaries quickly. Dictionary is still part of the, is still one of the data types that stores a collection or a sequence of values. So dictionaries, in Python. So the dictionaries in Python, first of all, their attribute, or maybe their unique characteristic, is that unlike the rest, the tuples, and the list, this one stores data in the key value pair dictionary, stores data. Let me say stores data in key value pair. A key value pair. And by the way, I think this is a very, very important thing to know, especially if you're working with the APIs, especially if you'll want to learn things like, you'll want to learn more about the RESTful APIs. It usually use the JSON, which resembles like Python objects dictionaries, basically. So this, I think, is very, very key thing to know. But then before we get there, the first of all, the characteristic about the dictionary. First of all, this one is ordered. The dictionaries, these are dictionaries should be ordered, right? Should be ordered. But then if it's ordered still, but you cannot access the elements with the because values are stored in key value pairs. So you'll be using the key because are unique key to access what is the value. So it is ordered still, but you cannot access the element with their index number because here you are using keys, not the index number. We are going to demonstrate that one in a few. And then another thing about the dictionary, this one are changeable. This one is changeable. Remember now both the lists and the dictionary, they are both changeable. These are similar characteristics between the dictionary and the list. They are both changeable. And the other thing about the dictionary also, this one does not allow the duplicates. This one does not allow the duplicates. And then it does not allow the duplicates. And then it can store data of any type. And also it is defined with this curly brackets. Now let's try to demonstrate these things, or maybe let's just try to present this to prove these statements. So first of all, let's try to get our object. Perhaps we'll call it person. Okay, let's use children. Children. Okay, let's begin symbol. Let's say child. And then you might want to store more information about the child. For example, you'll want to store information for example, the information like the name of the child, the age, and all that. So you'll be writing like, remember, for example, if you use name, it is a string, so it should be in quotes. So name. Then now the values are separated with the column, but then let me include it here. Key value pair separated with a column. Separated with the column. So you are going to say name. Then if the name is a string, you need to type it in quotes. So for example, when you say John. So this is now the value of this key name. And I remember, this is one item. This is still one item, a key value pair. So it's this like one element in this dictionary. So if you include things like also age, you can also include, for example, age. And then age is what? Is an integer. You could do what you could say. You could add there an integer, for example, 15. 15. So this is an example of a dictionary. And to check the dictionary, or someone told us, okay, how can we check the data type of this child object? Let me know the chat. How do we check to know the data type if it's a dictionary or not? Yeah, we're going to use the type function. Thank you so much. Type function. And then I will be passing out our object in the inside, which is a child. And then now the output is dict, of which stands for the dictionary, like it's a syntax for dictionary. So this is a dictionary. Dictionary. This is a dictionary. The output is the data type it is a dictionary. And remember in Python like objects. By there's something that we are going to talk about in a few, if time will allow, about classes and objects or natures of Python objects. Talking about the polymorphism nature of Python, such that there are some methods, for example, like a len. If you want to identify the number of elements in these tuples, we'll remember the function that we're using to identify the number of elements in these in a Python objects. Which function do we use? Let me know. Yeah, len function. Thank you. So we usually use the len. So we're going to say print, and then len. Len is a function. A function must have a parenthesis. Then in the inside, you specify what you're trying to identify the length. In this case, it's fruits. Is fruits. Then it's now returning the number of elements in this case. And these are fruits. So these are like one element, 2, 3, 4, 5, 6. 6 elements. 6 elements. And if it were in a list, it's still going to return like that number of elements in the inside. But then if it is in a string, for example, when you say A, then it is in a string. For example, let's say, let me use Nehemiah. So now when you use now the len here, it's going to return now the number of characters here. It's now return the number of characters is the elements in these strings. That's why I can see it is 8. So it changes. We'll talk about these attribute, these nature of Python objects, like the polymorphism in the characteristics, such that you can have a method or maybe a function or whatever it is, such that when you use it somewhere, it's going to work differently from another one. So we'll talk about those things later. But then in this case, we want to also understand these attributes here, if like in code now. So let's also include, for example, name, age, and then nationality, something like nationality. Nationality you can add in here. For example, don't know if you guys know Djibouti. Yeah, so it's a country. So the output here is going to be this dictionary's key value pair, starting the values, the items in the key value pair. Now you notice it is ordered, right? It began here with name and then age. Okay, sorry, name, the first one for name, then age, then nationality. So there are 3 elements. So when you use here a len, it should be 3. It should be 3. Now in dictionaries, the number of elements that are in key value pair, that's why it is returning at 3. So that's len function. That's how it can be used like in different contexts. But then we have understood that first of all, it is what it is ordered. And then now it's ordered, but then we cannot do it. We cannot change the elements with the index number because it's storing the values in key value pair. I know in list you could say, for example, a child, for example, if you wanted to modify index 1, elements and index 1, you could have simply say, you could have simply said what? You could have simply said, for example, you could have simply specified the index and then assign it a value. Assign it a value. I know this one is not going to work. Okay, let me see. I'm using the form of, or I should be a dictionary by there. But then I know it's still not going to work. But then let me try to modify to be, for example, James. Okay, like I don't know, city or something like that. And then so okay, sorry, you can see now it's not modifying. It's like it's trying to add in a new one, a new element in this case. So it's not modifying this element at index 0. It's trying like to add in a new element there. So you cannot, even though it is ordered, it's orderly, you cannot modify. But then if you want to modify, for example, the name, you can only modify the keys. You can only access the elements with their keys. Keys are like this. Remember, these are key, then this value. So if you want to modify, for example, the name, you could specify the name. For example, you want to modify the name to be something else like James. James, and then so the output is going to be this, right? So you can only modify the values. You can only modify the values. But there's something also that we also said here. It does not allow the duplicate. So let's try to have John, But then remember when I talk about the duplicates, I mean the keys. And also the duplicates doesn't mean 2, could be 3, 4, 5, like a repetition of items. So when I say here, another name John. So this one is going to only return, even though I change the value here to James, the output is going to be just one name. So you cannot have these duplicates, the keys to be duplicates, and you can use like other methods. Or like, for example, if you wanted to only know what kind of keys are here, how many keys are here, you could use the keys method. You could use the keys method, and the keys, okay, you will specify first of all the object. Let's say, for example, if you wanted to only return the keys, I mean this name, so you just specify the object, which is this variable child. Then use the keys method. It doesn't take any argument, keys. To get what the keys, this name, age, and nationality to know are the keys there. So these are the keys, name, age, and nationality is written in a list. Then, for example, if you wanted to return the values, you could use the values. The values alone, then it's going to return out the values. And then if you wanted to get I think let me use different cells in case someone wants to have the reference. So, so first of all, let's begin in the keys. And then values. And then, for example, if you wanted to return both the keys and values, you could use the items method. Method. You could use the items method. So it's going to return still the list, but then items separated in a column. But there's some methods as well behind these dictionaries. Now, for example, you can add, you can remove, you can modify, you can do other things. But then the key thing in this case is just to demonstrate these attributes. Because if you want to go to discuss everything, then I will never finish this onboarding program. Then this just to bring up to speed the beginners. So that's something about dictionary. So we've understood that it is ordered, but then even though it's ordered, you cannot access element with their index. You need to use the keys. You need to use the keys to identify them, or maybe get the values. But like you cannot modify with their what with their index number. And then I stores data in a key value pairs. Then it's changeable. We demonstrated earlier somewhere. We demonstrated here. And then also it does not allow the duplicates. And then also it can store different data types like we have demonstrated here. Yeah, so this is the nature of the Python dictionary. But the dictionary is also a lengthy topic. If you want to learn more methods or all the methods, it's a lot. It's a lot. But a quick one for beginners, I think this could be best for you. Let me know, guys, if it's clear up to here on the dictionary, because I want to talk about the few things before we close it, because I see also time has gone. Is it okay, guys? Is it clear?
Hi, Mr. Nehemiah.
Hello?
Can you hear me?
Yes, I can hear you.
So my laptop battery is currently down.
Yes, yes.
So this is just like I have just like 10 minutes left for this laptop battery. So please, can we just like maybe round up earlier? Honestly,
Oh,
because
sure.
I'm recording on my end so that it doesn't pause in between.
Oh, sure. But there, yeah. I think let me just stop it here. Yeah, but there, since Python is lengthy, I thought I could have finished these things in one lecture, but it's a bit lengthy, even though I've tried to summarize. But then, guys, there's some things that I'll talk about perhaps in the next class. I'll talk about the if the conditional statements, the loops, and then we'll talk about the functions, classes, and objects. And the objects, guys, I think I need to, but then the topics that we demonstrated or maybe we said in this, we shall make sure that we have address all aspects here. I don't know where, let me see. So there's a lot that we had listed in this one, but then it's a bit tricky to cover. But yeah, I think we will be able to make it. We'll be able to make it, guys. So we can finish Python tomorrow. The basics for beginners. Remember, it's quite detailed. Python is very detailed. If you want to learn it like everything, it will take you like many years. But for beginners, I think this could be best. So the idea is that I've tried to make it very simple or easier. I've used like a basic things to demonstrate, but then in the production or maybe like when you want to do something, you need to like combine several things to achieve like whatever you wanted. So I will have a day where we'll be doing the projects. Like I will try to use these technologies or maybe the skills that we're acquiring to do something. We'll try to demonstrate maybe after the end of Python. So guys, because of the power issue, I think let me hand it over now to Aisha, and then we shall continue tomorrow. I think we might be able to finish tomorrow. Yeah, but it's also better for people to understand. So thank you so much. I think I hand it over to one Dev, to Aisha.
Thank you very much, Mr. Nehemiah. That was intense. Guys, if you, oh my God, your battery is low. Sorry. If you know you understood, just quickly use your comment section and say, I understood. Like, this class has been really intense. I mean, you guys are like, honestly, this is a lot, right? People pay for classes like this, and oh, great. I need more comments. Let's have more comments, please. Guys, let's have more comments because I need to quickly rush up this class right now so that this laptop does not go off. Yeah, thank you very much, guys. Thank you. Yeah, so yeah. So guys, Mr. Nehemiah gave one assignment. I forgot to drop it, honestly, and I'm so sorry. I'll drop the assignment in the community once I get to charge my laptop, right? I'll drop the assignment in the community, yeah. So that will be all for today. I wouldn't want to talk too long for this class. I wouldn't want to I wouldn't want to say too much because my battery is already on like danger, right? Yeah, so yeah, this is day 6 and we are still like we are still coming back here at the same time tomorrow. So make sure that you set your alarm and you're here early tomorrow. The same time, the same place. Yeah, I would continue tomorrow. I'll see you guys tomorrow. Do have a wonderful rest of the day. Bye, everyone.